It's very, very hard, and it has always been traditionally almost impossible to manage wisely a fish that moves over vast distances.
As we see now the distributions under climate change, fish stocks may be going north where they weren't up there before, or vice versa, some might be going further south.
When we catch a shark or a tuna off the northeast coast, it's not just using that area, it's crossing the entire ocean.
So we don't know anything about the sharks, the mahi-mahi, the sea turtles, all that kind of pelagic species that cross the oceans, and we have no idea of where they go.
So something's happening to them in the ocean, and we have no idea what.
OTN is the Ocean Tracking Network. It's a synthesis, really, of two Census of Marine Life projects, one called the Pacific Ocean Shelf Tracking Project and the other called the Tracking of Pacific Predators Project. The POST project uses curtains of acoustic tags that go out from the shore to the edge of the continental shelf. It can use these acoustic tags to track very small animals, things as small as salmon smolt, 10, 12 centimeters long.
A lot of ecosystems are driven by what small animals do. You know, large fish usually go where bait fish are. It provides an extra piece of the puzzle, a very complex puzzle, to be able to tag the smaller animals.
The other project uses tags that talk to satellites or archive data. Those are really only useful for animals that come to the surface, like seals or whales. The animals have to be big. What the OTN is trying to do is to have one global system that will both gather information about the ocean from big animals that travel over long distances, but also gather information about small animals as they migrate.
We know so little about the oceans, so it has tremendous implications for increasing our knowledge and also for better management of the oceans.
It's pretty clear that the weather is changing. All you have to do is look at the latest pictures of the Arctic to know that it's getting warmer up there, and when all that ice melts, it's going to change the way things are here. It's going to change the way the animals behave.
We've already found some amazing similarities between what tuna do and what seals and sea lions do, for example.
And, you know, in the early days, we didn't know this before tracking started.
So we put out the Halifax line the first time we downloaded it, and we only got to the first 8 receivers. But there we had a hit of one of the salmon coming up the shelf 6 kilometers offshore. Now we know that at least some of the salmon move up through that corridor. And that's knowledge that no one has ever had in the last 80 years of studying salmon movement. So I think, to me, you know, getting that first bit of data coming in from that line, that's a big moment.
The idea with OTN is that they will be useful for scientists in 5, 10, or even 20 years from now, so that you really had some value to your data.
DAL is very well poised to be in this situation given their location and the number of marine scientists and researchers that are not only at Dalhousie but neighboring institutions.
Dalhousie's biology department has always been absolutely top-notch and always been fairly international, but this will truly make it global.
As wonderful as this all is and sounds, it is a monumental undertaking. And I think everyone here is really acutely aware of the work that's ahead of us and the kind of complexity we're going to have to deal with and the way sort of out of the box we're going to have to think. And so it'll be just very exciting to see what the future brings.
OTN, as it's designed, will allow all of the interested scientists and countries around the world to cooperate to providing the data to start to be able to understand how our actions influence changes in the planetary environment and how we can change what we do to influence the environment around us, in this case the marine environment. So I think that's where OTN data will really be useful for the global commons.